Hi, and welcome to this video on determining volume given income before and after changing parameters and maximum net income. We're working on the following problem. Tyler, a carpenter, has the capacity to produce and sell 76 tables every year at $3,000 each. The variable costs are $1,000 per table, and fixed costs are $40,000 per year. There are three parts. A. How many tables should he produce and sell to have a net income of $76,000 per year? And we need to round up the answer to the next whole number. B. What is his net income at maximum capacity? And we need to round the answer to the nearest cent. And C. Calculate the number of tables he needs to sell to have a net income of $87,000 per year if the selling price of the tables is reduced by 13% and variable costs increased by 15%. And we need to round up the answer to the next whole number. To work with a problem like the one we have here, we need to understand variables involved. Let's start with 76. 76 is the capacity of the facility. Tyler has the capacity to produce and sell 76 tables. So let's write here that capacity equals 76. Now, Tyler sells tables at $3,000 each. Those $3,000 correspond to the selling price per unit. The selling price per unit is the amount a business charges its customers to buy a single unit of item produced. The selling price per unit is denoted by P. So here we have P equals $3,000. Okay, next, we work on variable costs. We have that Tyler has variable costs of $1,000 per table. Variable costs are denoted by VC for variable costs. And examples of variable costs are costs of all materials, cost of labor, and revenue-related costs such as sales commission, royalties, etc., that are necessary to produce one item. Here, variable costs are $1,000. So we have $1,000 for VC. And with that value for variable costs, we can find the total variable costs. The total variable costs correspond to a multiplication of variable costs by the number of units produced and sold. And that number of units produced and sold, and this is denoted by Q. So here we have 1,000 multiplied by Q. We don't know the value of Q. We don't know how many tables are produced. So we just leave total variable costs written in terms of Q this way. Next, we have that Tyler has fixed costs of $40,000 per year. Fixed costs are costs that remain the same regardless of the number of items produced to sell. Fixed costs are calculated for a specific time period, in this case per year, and are based on the production of a predetermined quantity of products for that period, in this case 76 tables. Examples of fixed costs are administrative salaries, rent or lease of a facility, utility costs, insurance costs, property taxes, equipment rental or depreciation, and marketing and advertising costs. These are all considered fixed costs since any variation is infrequent, and the amount does not directly depend on the number of units produced. In our case, we have fixed costs of $40,000. So we write FC for fixed costs equals $40,000. Okay. Now that we have identified all variables that the statement has to do with, let's work on part A of this problem. We want to know how many tables we should produce or Tyler should produce. So we want to know Q. We want to find Q so that the net income is $76,000. $76,000. The net income is the same as the net profit. So here we have that profit will be $76,000. Net profit defines the success of the business by determining the difference between the total revenue. Here we have the total revenue earned and the total costs incurred in the business. Profit is total revenue minus total costs. The total revenue of a business is computed by multiplying the selling price per unit at which items are sold, the P, by the number of units sold, as shown in this formula, P times Q. So we have P, that is 3,000, multiplied by Q. That's what TR is, total revenue. As for total costs, we consider fixed costs and total variable costs. Fixed costs are $40,000, and the total variable costs are 1,000 multiplied by Q. Okay. So, according to the statement of part A of this problem, we want to make sure that the total revenue, the amount of money received or brought into the business from the sales of the items produced and sold, minus the total costs should be 76,000. That's what we want to have. And we want to find Q so that this is true. So we're trying to find Q so that 76,000 equals 3,000 times Q minus 40,000 plus 1,000 times Q. In other words, we need 76,000 to be equal to 3,000 Q, and the minus affects everybody in this bracket. So we have minus 40,000 and then minus 1,000 Q. We can move this minus 40,000 over to the left to get that 116,000 should be equal to, and then 3,000 Q minus 1,000 Q is 2,000 Q. So Q turns out to be 1,000 divided by 2,000, and that gives us the number 58. So 58 tables should be produced and sold to have a net profit of $76,000 per year. All right, let's move on to part B of this problem. I'm going to erase the board to show the solution to part B. Okay, in part B, we want to find the net income or net profit. Here we're looking for profit. That's the variable. Oh, I think this was total variable costs. There you go. We're trying to look for the net income at maximum capacity. And the maximum capacity is 76 because that's the capacity that we have here. So Q is 76. Okay. If Q is 76, then we have that profit will be written in terms of Q. Remember that profit is total revenue, take away total costs. Here, total revenue comes from multiplying P by Q. We have $3,000 multiplied by 76. When we multiply those numbers, we get 228,000. That's the total revenue. And the total costs are the addition of fixed costs and the total variable costs. So we have 40,000 plus, those are the fixed costs, plus 1,000 times Q, and Q is 76. So we get 116,000. Then the profit at maximum capacity is given by 228,000 minus 116,000. And that subtraction is 112,000. The answer to part B of this problem is 112,000. That's the net income at maximum capacity. There's no need to round the answer to the nearest cent because we already have that the answer is a whole number. So that's all for part B. Let's move on to part C of this problem. Let me erase here. And now we write all we need to write for part C. In part C, we need to calculate the number of tables to find Q that Tyler needs to sell to have a net income of $87,000 per year. So here, profit is 87,000. If the selling price of the tables is reduced by 13%, so now the new price is 100 minus 13% of the original price, and that gives us the number 87% of the original price. Okay. When the selling price is reduced by 13%, that means that the new price is 87% of the old price. And now variable costs increased by 15%. So the new variable costs will be 115% of what we had for variable costs. Okay. So the new price is going to be 87% of the price. So now we have 87 as a decimal, 87% as a decimal multiplied by 3,000. Get that the new price at which tables are sold is 2,610. Well, the new variable costs will be the decimal corresponding to 115% multiplied by what we had for variable costs, and that's 1,000. So the new variable costs are $1,150. Okay. So then the new total variable costs will be $1,150 multiplied by Q. The total variable costs are costs that vary directly with the number of units of items produced. We multiply variable costs by Q. We have variable costs of $1,150. So the total variable costs, the new total variable costs will be 1,150 times Q. And we need to find Q, so profit is $87,000. One profit, which is total revenue minus total costs, to be equal to the 87,000. Now the total revenue comes from multiplying the price, which tables are sold by number of units sold. We have 2,610 times Q. While the total costs come from adding fixed costs and the total variable costs. So we have 40,000 plus 1,150 times Q. So we're saying that we want 87,000 to be equal to 2,610 times Q minus 40,000 plus 1,150 Q. We're saying that 87,000 should be 2,610 Q minus 40,000 minus 1,150 Q. Notice that the minus affects everybody in the bracket. We have this equation that involves Q and some numbers. We're trying to find Q. We got to this equation by forcing profit to be 87,000. So here we have 2610 minus 1150, that's 1,460 Q. And when we bring the 40,000 over to the left, we get 127,000. So Q should be 127,000 divided by 1,460. And that number is 86.986, etc. And we're told that we need to round the answer up to the next whole number. We write 87. There is 87 here. Answer is rounded up to 87. So we have that Tyler needs to sell 87 tables to have a net income of $87,000 per year if the selling price of the tables is reduced by 13% and variable costs increased by 15%. Right, that's it for this problem. We used the formula profit equals total revenue minus total costs multiple times. If you have questions, please write comments and I will be happy to help you. Bye-bye.